Let's learn about photochemical smog. Yuck, look at that. Ugh, hate that stuff. Okay, photochemical smog is basically what it sounds like. It involves photo, that's light, and chemical reactions that make smog or cloudy air. Now, here's how photochemical smog, and you see it all the time here where we live. It's formed basically when nitrogen oxide compounds, NOx, react with volatile organic compounds in the air. So basically, we have VOCs and NOx compounds mixing in the air, but that alone isn't enough for it to work. So they can't react to form ozone on their own. But what happens is when sunlight shines on them and they get warm and get exposed to ultraviolet light, that triggers the reaction. And so basically, when that happens, we get photochemical smog. Now, where does the NOx come from? So the nitrogen oxide is primarily derived from, as we learned in our last presentation, from exhausts from combustion. So when we burn fuel, fossil fuels, in cars and in power generation facilities and factories, an unintended consequence is that nitrogen combines with atmospheric oxygen to form NO and NO2, which collectively we refer to as NOx. Well, then what happens is there's volatile organic compounds. A lot of that is unburned gasoline and other fossil fuels that come out of the exhaust of cars. It's also industrial solvents, cleaning products, and even compounds given off by green plants. There's a number of carbon chain organic compounds given off by plants, and so these get into the air as well. So the combination of NO and NO2, atmospheric oxygen, and these VOCs, in the presence of heat and sunlight, they will react. And without going into the details of the actual chemical reaction, O2 in the atmosphere ends up becoming O3, which is known as ozone. And that is something that is really not very healthy for us. So basically, here's another diagram showing. So we got nitric oxide, nitrogen dioxide, and hydrocarbons coming out of vehicles. We have NO, NO2 coming out of power generating facilities. We have sources like paint and gas stations. Like when you pump gas out of your car, that puts VOCs into the air. And so then we also have atmospheric oxygen, which is O2, and in the presence of ultraviolet light and heat, they turn into basically uh, three things that we're going to concern ourselves with. One is ozone, what we call ground level ozone, as opposed to stratospheric ozone. And you should be prepared on the test to be able to explain the difference between stratospheric ozone, which is good for us, and ground level ozone, which is bad for us. So ozone, as I said in the previous presentation, it tends to break apart, releasing monatomic oxygen atoms into our bodies, our mucous membranes, and it's quite a strong irritant. It causes a lot of health problems. It's one of the worst of the pollutants that we get exposed to. Um, but in the upper atmosphere, it's a good thing because we're not breathing it, but it protects us from ultraviolet radiation. And the stratospheric ozone has nothing to do with nitrogen oxides or VOCs. It's just purely ultraviolet light interacting with atmospheric oxygen. However, down here at ground level, when we say ground level, we're talking about up to a height of about half a kilometer. It's the combination of is a chemical reaction caused by NO and NO2 with hydrocarbons and other VOCs, even ones coming out of plants, and atmospheric oxygen together in the presence of light, producing ozone, uh, PAN, which we'll talk about in a minute, and aldehyde compounds. So let's just talk about these other ones. So we have peroxyl. I'm going to get this right. Peroxyl acetyl nitrate, which basically is this, and then you can connect this to some other carbon or some other. It doesn't even have to be carbon, but basically this functional group, when added onto some other atom or molecule, is not good for us. All right. And then aldehydes, like formaldehyde, basically you have this functional group attached. So these get produced in the atmosphere as a result of these chemical reactions, and these compounds are known to cause irritation of the eyes and throats and mucous membranes, lung damage, and damage to plant growth. Now, one thing about photochemical smog that is interesting, and it's beneficial to know because it helps urban planners try to deal with it, is that its levels vary with the time of day. Because remember, you need several things. You need the appropriate chemicals, basically nitrogen oxides, which come out of car exhaust and factory exhaust. You need oxygen, which is always present in the atmosphere, fortunately, and you need volatile organic compounds, which tend to not have I mean, they have a little bit of a periodic increase and decrease throughout the day. But what definitely increases during the day is sunlight and temperature. So what happens is in the morning commute hours, people on their way to work drive cars. Those cars put NO and NO2 into the air in fairly high abundance, which we see here. And then what happens is, as the sun comes up, the ground gets warm, and those VOCs are just present in the atmosphere in normal abundance. But what happens is, uh, as the sun comes up around mid morning, all of a sudden we see that as we get towards noon, the levels of ozone will increase quite significantly and then begin to drop off in the afternoon. So we definitely see in the course of a day a gradual increase as the morning wears on towards noon of ozone. And that's because of the interaction of the VOCs and the nitrogen oxides with sunlight. So an example of the city of Los Angeles. Uh, as you can see, early in the morning, the air can be clear, and by mid morning, it can be quite smoggy. And that's just because as people head to work, they're putting a lot of NOx into the air, as well as VOCs. And then when the sun comes up, it hits them, and we get our photochemical smog. And this stuff is quite bad for us. Ozone is really, really bad for people. Now, how can we reduce it? Well, you got to reduce the progenitor compounds, right? So you got to reduce the VOCs and you got to reduce the NOx. Well, how do you reduce the VOCs? Well, one of the main ways they found that VOCs get in the air, and sometimes it just comes it comes out of our exhaust without being burnt. If you don't get the right oxygen mix in your fuel, then in addition to getting carbon monoxide, you also get unburnt fuel, which is VOCs, which is a big part of the problem. But also, what they found is that when people pump gas, it's volatile, and so it just comes out of it. You can actually see it. If you can smell it, it's getting into the air. You smell VOCs, and so what they found is just by simply putting some sort of a little seal on here can do a lot to prevent. So they realized is a lot of urban VOCs just comes from the simple act of fueling cars. That's when a lot of it comes out. There's quite a bit of elaborate ways of reducing, making a seal to reduce the ability of these VOCs to get into the atmosphere when we do this. Another thing we can do to reduce VOCs and NOx is a device called a catalytic converter, which is in the exhaust of cars in most developed nations. So what happens is the gas coming in from the exhaust gas from the internal combustion is going to contain a few things. It's going to contain HC, that's hydrocarbons. Those are VOCs. It's going to contain nitrogen oxides, and it's going to contain carbon monoxide. All three of these things are bad. Now, carbon monoxide is separate from photochemical smog, but I'll just talk about here. As these things pass through a catalytic converter, there is a catalyst in there. So it is basically a honeycomb of ceramic that is embedded with platinum and palladium. And these things catalyze the reactions of NOx into N2 and O. So they do take nitrogen oxides and turn them back into nitrogen and oxygen, which don't cause photochemical smog. And the HCs, the hydrocarbons, the VOXs, they just react with oxygen, turning into CO2 and H2O. So we come out the other end is water vapor, carbon dioxide, and nitrogen. Now, carbon dioxide is basically the chemical that is most widely responsible for global warming. It doesn't do anything about that, but it greatly reduces photochemical smog because we're getting rid of the NOx and the HC, the hydrocarbons. Now, another thing that people have found can really help a lot is the use of electric vehicles. Electric vehicles have no direct, they don't have a tailpipe. There's no exhaust coming out of them. They have a battery that you have to charge up. All right. And then you drive it and there's nothing coming out of it. Now, That might seem like a miracle, but keep in mind that energy has to come from somewhere, and that it's electricity. And electricity in the developed world and just all over the world is generally produced by burning coal and natural gas, mostly coal. So if we take the entire fleet of cars in the Seoul metropolitan area and convert them to electric, it doesn't mean that we're not polluting the air to the same extent, but we are putting that pollution somewhere else. We're putting it where the factories are, and they have a little bit, maybe better ability to monitor and mitigate the pollution at a smaller number of sources than you get from a million cars. So it definitely helps. Plus, too, the cars are distributed in the area where people live, and the power plants are often not where people live. So this definitely also helps with photochemical smog. Okay, thanks for watching.